Hello everyone. This is the 5G new radio tutorial, and in this lecture we will talk about 5G spectrum, about high frequency operation and spectrum flexibility. Also, we will talk about the overview of transmission scheme, bandwidth part, and frame structure. So let us start with frequency ranges, and as many of you have heard, there are two major frequency ranges defined in 5G operation. The first one, which is called FR1, is from 450 megahertz to 6000 megahertz, and it is commonly referred as sub-6 gigahertz. And right now, uh, worldwide vendors that are providing solution for 5G, providing the solutions on this frequency range 1. And second frequency range is from 24,250 megahertz to 52,000 megahertz. This is frequency range 2 and commonly referred to a millimeter wave band. So this is exactly the frequency band that promises us a lot of performance gain, a lot of innovations, new solutions, and new experiences. But so far, it is not yet employed in the industrial development. So you can see that this table in this lecture we will have a lot of tables, and you can see that this is called table 34.1011 table 501. So this is the name of the technical document. As in last lecture we discussed, in order to know 5G specifications you have to read technical reports or technical specifications. So in this case we have technical report 38.101 and table 501. So if you download the documents, it's open access. You can open it and see the same table. So for each frequency range, we have different bands. So you can see two tables, table 521 and table 522, and those are exactly the operating bands. So you can see N1 is 9020 to 9080, and 2 8050 to 9010, and so far and so on. This is uplink of operating bands from low frequency to up frequency. And the duplex mode that they use here is FDD or TDD. So there are much more operating bands because the table is very huge and couldn't fit in one um, slide. I just crop the part of it and just let you see an example how the specifications look like. And the second page is again NR operating band, but for frequency range 2 or millimeter wave range. And we can see the bands that are commonly defined here. One thing that I want to bring your attention to is that in lower frequencies, the duplex mode that we're using is FDD, which is similar to LTE. But for higher frequency range, almost always you will see that it is TDD being used. The reason for that is because for high frequencies, we have a very strong signal attenuation. Therefore, we would rely on technologies called massive MIMO and beamforming. And it turns out that in industry, those technologies are easier to uh, produce with the TDD duplex mode. So speaking about new frequency ranges, we now move to another uh, essential component of the 5G, and it is called 5G numerology. So in traditional LTE networks, we assume to have one frequency resource block composed of 12 subcarrier, and those subcarrier spacing was 15 kilohertz. Now, because we are moving from lower frequency bands to upper frequency bands, we now can have much wider bandwidth and much wider resource block. That's why 5G makes the use of different numerologies. So 0, 1, mu equal to 0 refers to a 15 kilohertz subcarrier spacing, and 1 for 30 kilohertz, 2 for 60 kilohertz, 3 for 120, and 4 for 240. So we can see that as the subcarrier spacing increases, the size of the resource block increases proportionally. So you can see for traditional LTE it was 180 kilohertz, and for 5G it's going to be up to 2880 kilohertz. So that's of course the biggest difference between LTE and R. And looking at spectrum, so combining previous two slides, where in first slides we talk about frequency ranges, and in second slide we talk about the numerology, we can see that subcarrier spacing 15, 30, and 60 is going to be used for sub 6, and with max carrier bandwidth 50, 100, and 200 megahertz, while subcarrier spacing 60 and 120 would be used for millimeter waves. An important thing, of course, as I mentioned, those two frequency ranges, those are just specifications, but it doesn't mean that each country would use exactly those frequency. So on the chart below, we can see that major players, which is European Union, America, Korea, Japan, and China, they are using different bands, which is of course subject to internal regularization organization, which basically permit or not permit use certain frequency. So both EU and America are gonna use the sub 1 gigahertz frequencies. So it's 600 and 700 megahertz. The major frequency that is used by its provision that it will be used by each 5G vendor would be from 3.1 to 4.2 gigahertz. That's exactly a new band that became available, and the main band that will be used for millimeter wave would be 26 to 28 gigahertz. The reason for this frequency 26 to 28 to being used is because it has something to do with the chemical composition of air, which leads to smaller signal attenuation at those frequencies. Yep. So after speaking about new frequency bands, numerologies, we have to talk about NR physical time frequency structure.